Hello everyone. Can you just give me a moment? I'm going to talk about a random access memory footprint reduction of the generated tests for AUTOSAR runtime environment. AUTOSAR is leading standard in automotive industry, and part of that standard is AUTOSAR runtime environment, which tests are going to be used in this paper. MotionWise platform is a software platform which controls a large number of ECUs inside vehicles, and for it to communicate and to work correctly, automated testing is conducted. Something about MotionWise platform: it is a safety software platform, and it is developed by TT Tech, fully compliant with AUTOSAR, and it runs inside embedded systems in vehicles, and it enables communication between ECUs. Testing this platform is done with automated testing. So proposed methods in this paper are based on loops, variables, structures, and arrays. Loop optimization methods used are loop unrolling and loop inversion. Loop unrolling optimizes loops with small number of iterations, so it reduces total number of loop iterations, but in general increases total code size of the program. Loop inversion replaces while loops with if conditional expression, followed by do while loops, and it avoids pipeline stall. Variable methods in this paper are based on variable data size, data type size reduction, so each variable data type is reduced and then tested for errors or overflows. Structure optimization: we have 32-bit memory width on used systems. Structure variables have to be aligned within memory, so the goal is to use as low as possible memory addresses of the system. Array optimizations: so one array can be used for more builds or programs, while different builds can require different size of one array. That is fixed using macro functions. So we defined the maximum size of array used in each program separately. Method that was not tested on the test development board but was using different compiler optimization levels. So compiler used in this paper is ZINC Tricore version 4.2 R2. Those levels of 1 or 2 can affect the total consumption of random access memory, read-only memory, and processor usage, and they're just used to show if there is any room for further reduction of random access memory footprint. So results: we built 4 separate programs using test program code. It was tested on Infineon Tricore AURIX on board driven by Infineon Tricore AURIX microcontroller. So the best methods has shown that array optimization brings best results on ITF build, but we can see on the graph here that there are no results using that method on PFF build. So total RAM consumption reduced is 4%, around 4%, but the most important thing here is that 98% of tests passed before using those methods and 98% of tests passed after applying proposed methods. So is there any room for improvements here? Of course there is. So O1 and O2 compiler levels have shown great results, saving additional 22,000 bytes or almost additional 11% of random access memory ITF build. As I said, those builds were not tested on development board due to technical requirements of the project, but can be and are in this situation a good indicator of possible random access memory footprint reduction on MotionWise platform. So in conclusion, for autonomous driving to be possible, large quantity of computing power is needed. So to reduce the total cost of vehicle production, total computing power has to be reduced. This study tested proposed methods and brought up to 4% of random access memory consumption reduction with successful testing and additional 10% of reduction using different compiler levels. These compiler levels show possibilities of further reduction of random access memory usage, but were not tested on test development board. That's it. Thank you for your attention. Questions?
So I have one question for you. So you did not achieve the same optimization results on all builds. So can you explain why?
Different builds use different amount of loops, variable structures, and arrays. So the same amount cannot be achieved on all builds because of that.
Okay, thank you.